today we are going to be talking about another type of transformations. We're going to be talking about rotations. As you know, to rotate something means to turn it, right? Okay, so they will specify how much they want you to turn something in degrees. As we know, an entire rotation, if I go full circle, how many degrees is that? 360, right. If they tell me to go 180, that tells me I'm going to go halfway, right? Okay, anything more specific than that, like if it's a 90-degree rotation, that would just be a quarter of the way, right? If they want you to go something smaller than that, it'll have markings on your paper for you. But we should know that 90 is a quarter, 180 is half, right? And that 360 is a full circle. All right, so up here at the top, it wants our definition. Our definition is a rotation about point O through an angle of x degrees is a transformation that maps each point P of the plane with a point P prime such that an angle POP prime is equal to x degrees. So it's going to create an angle with your rotation from your original to the point you rotated at to your new, okay? And you'll have some original segment, OP, from the center to your original, and some new line segment, OP prime, from the center to your new point. That point O is what we will call our center of rotation. So the point they tell you to rotate around is called your center of rotation. So x degrees is the angle of rotation. Okay. So here on example 1, it says if PQRST is a regular pentagon, regular means all the sides are the same, all the angles are the same. So basically, it's a side with all congruent sides and angles, okay? And O is your center, so this point right here is your center. Find the following pieces. All right, so instead of being split into 4 quarters, like what you guys have just previously told me would be 90 degrees for a quarter, 180 for half, 360 for a whole, I am not split into quarters if I draw a line from O, right? If I draw a line from O to P, O to T, O to S, O to R, and O to Q, it's going to split it into more than 4 sections, right? We'll have 5, right? Okay, so like you said, we would have 5 sections. So what we would do is divide 360, because all the way around is still 360, into 5 sections. And what is 360 divided by 5? 72. All right, so that's going to tell us that if I was going from P and rotating around O and going to T, from here to here must be 72 degrees. All right, so each section basically is 72 degrees. All right. Okay, so now that we know that each section is 72 degrees, it says here they want us to rotate clockwise 72 degrees around point O of point Q. So that means I'm starting, with my point Q, okay, my point Q here, and I'm going to rotate clockwise 72 degrees. So basically 72 degrees, as we said, means 1 section over, right? So if I go 1 section clockwise from Q, what point would I land on? P, right. Clockwise would mean this direction. So 1 section over would put me at point P. So a 72 degrees clockwise rotation would put us at point P. All right. Then they say the 144 degrees clockwise rotation about point O for point R. So this time I'm starting at point R and I'm going 144 degrees. How many sections would 144 degrees be? 2. Okay. So if I'm going to go 2 sections. Which way did it say to go this time? Counterclockwise, so I'm going the opposite way, right? So from point R, I'm going this direction, 2 sections. Where would I land? T. So 1 section would put me at S, 2 sections would put me at T. All right. Then they ask for a 360-degree clockwise rotation of point P. Well, we just said 360 would mean we go all the way around. So if I start at point P and I go 360 degrees clockwise, I should end up back at point P. Okay, so if they give you a figure, it's a little bit easier because you have points to land on, right? Okay, and there were only these points on the outer edge that we had to worry about. But let's look at example 2. So on example 2, there's obviously a whole lot more going on in the picture, right? So that's what we're going to use this for, just to help us keep it straight for the time being. So everyone should have one of these, and everyone should have a compass. You don't need the pencil in the compass, you just need the compass. And then you're going to use your writing utensil to mark everything. Okay, so let's see here. Part A says that we are going to rotate 90 degrees clockwise about point Q. All right. And we are rotating the segment JK. So I'm going to take my patty paper and I'm going to put it right on top of that figure. Okay, and they said we're supposed to be rotating what? 90 degrees in the clockwise direction of which segment are we moving? JK. Okay, I'm going to take my patty paper here and I'm going to trace the segment JK and label it. So there's my J, my K, and there's the segment that I'm moving. Okay, so now that I've traced that, now I'm going to take my compass, and they said we're rotating around which point? Q. So you're going to take your compass and put the pointed sharp end on top of Q. Okay? And if they said to rotate 90 degrees, this whole big picture is a square, right? So that would mean to rotate one section. Okay, so now I want you to spin your patty paper for one section. And where did that put JK? On top of LM. Okay, so if I was to rotate it 90 degrees, apparently it ends up on LM. So that's my answer here. Okay. All right. Okay, now I'm going to take my patty paper, put it back on top, put it back on where original JK was. For part B, they said we're going to rotate what? 90 degrees counterclockwise, so this time the other direction, and we're rotating the triangle HIP. All right, so here's triangle HIP. I'm going to trace it out on my patty paper. Okay. And again, they said my center of rotation or my point of rotation is Q again, right? So I'm going to take the sharp end of my compass and put it on Q and rotate 90 degrees counterclockwise. So that would just mean to go one section, right? So one section, the opposite direction. So what would it land on top of? O and F. Good. Triangle O and F. So that's what I write down. So this lands on top of triangle O N F. It doesn't matter what order you list the three letters in. You could do F-O-N, N-O-F, O-F-N. It doesn't matter. All right. Okay. Then it says to do a 180-degree rotation about point Q for FM. So now I'm going to take my patty paper, put it back on top, and I'm going to trace FM, which is down here. All right. So again, I'm still rotating around Q. Okay, so they said we're going to go 180 degrees this time, right? So does it matter which way I go? Because 180 degrees should just be halfway. All right, so it doesn't matter which direction that you turn your paper in. You're just going to make two turns. So 1, 2. All right, so what does FM land on top of? All right. Okay, and then the last one here says a 90-degree rotation clockwise about point P. All right, so put your patty paper back on top and trace out your triangle HOP. So HOP is here. Okay. This time, what did they say that we were rotating about? Which point? P. So you put the sharp end of your compass on point P this time instead of Q. So that's my center of rotation. And they said to rotate which way? Clockwise. How many sections? 90 degrees, which is 1. Good. Okay. So if I rotate around point P one place, where does that put me on top of? HIP. Good. So triangle HIP. All right. Okay. So then they've got one more thing for us down here. They give us a definition. It says a figure is said to have x degrees of rotational symmetry if the figure can be rotated x degrees about a point so that the pattern appears identical to its original position. All right, so this one has a little bit of a formula to it, but something we need to know is that your x degree can't be any larger than 180. Anything larger than 180, it starts to become a repetition of itself. Okay? Because if it did something in the first half, it's probably going to repeat itself in the second half of rotation. So, can't be larger than 180, all right? And these are going to be our 3 steps for finding rotational symmetry. Your first step is whatever figure they give you. For example, here they gave us a square, is to find how many lines of symmetry you can draw. So find the number of lines of symmetry that your figure has. All right. Our step 2 is to take that number. So if yours has 5, like ours did at the top, or like I started yesterday, if it has 2, however many it has, you divide 360 degrees by that number. So divide 360 by your number of lines of symmetry. And like we said here, your rotational symmetry can't be larger than 180 degrees. That means you would only list all of your answers. So list all multiples of x, your answer, that are greater, or that are less than or equal to 180 degrees. Okay, so for example, we have a square here, right? Where could I draw lines of symmetry in a square? Down the middle, okay. Anywhere else? Horizontally. Anywhere else? Diagonally. So both diagonals. That's probably it, right? So how many did we just draw? 4. Okay, so step 1 was to find them all. We said we found 4, right? Step 2 is to divide 360 by however many you found. So we're going to divide 360 by 4. And what is 360 divided by 4? 90. Good. So my answers would be 90, because 90 is less than 180, right? And any multiples of 90 that are less than or equal to 180. So 90 times 1, it's just itself, right? 90 times 2 is 180. And is that less than or equal to 180? Yes. Okay, so I could list that one. But 90 times 3 would be 270, which is too big. So these would be my 2 answers. All right. So now that we know the process, they want us to do that for A, B, C, and D here. Okay. So I'm going to give you just a second. I want you to go through and draw your lines of symmetry on each one of those, and then we'll share in just a moment. So let's see here. For figure A, how many lines of symmetry did you guys find? 8, right. I can go here and here. But if I turn my shape, that means basically I could go in the middle of every single one of these lines, right? That means I also could go through all the vertices as well. So oops. I'm not very good at drawing straight here, guys. Sorry. Okay, so we do have 8. So if I was to apply my rule, then I'm going to divide 360 by 8, right? What do I get when I divide 360 by 8? 45. All right, so I would list 45, right? And all multiples of 45 less than or equal to 180. So I'd have 45, right? What's 45 times 2? 90. Okay, so that one works. What's 45 times 3? Good. And what's 45 times 4? 180. And that would be where we'd have to stop, right? Anything larger than that would be repetition. Okay. All right, for B, how many lines of symmetry did you guys draw? Just 1. All right. So I'd have 360 divided by 1, which is just 360, right? Okay, so is 360 less than 180? No. So this has no rotational symmetry. All right. What about on C? How many lines of symmetry did you draw? 5. Yeah, we did this one yesterday or on the notes, or maybe the day before. I don't remember. So we would have 360 divided by 5, which is 72. Good. So I could list 72 degrees. And what 72 times 2? 144. Can I list any more? No, the next one would be too big, right? Okay, and then D. How many lines of symmetry could I draw on D? How many? Okay, so I'm assuming our 2 were this one and this one. Could I draw one here? Yeah, they would match up, which means I could also draw one here, all right? So this one actually has 4, right? So 360 divided by 4 is good. So I could list 90 and what else? 180. And that would be it. All right.